be. So I need this distance here. So we're going to calculate delta x, and you can see it's not very difficult. I need this distance divided into 6 equal pieces. So to find distance, the process is subtract. So 4 minus 1, divide by the number of pieces you want. So I can see the heights are going to be a half a unit apart. So if this is 2 and this is 3, my partitions are going to be at 1.5, 2, 2.5, 3, 3.5, and 4. That's giving me 1, 2, 3, 4, 5, 6 rectangles, all technically the same width of a half. So for an upper sum, looking at this first rectangle, would I want to use the left edge or the right edge? Well, obviously the left edge if I want to stay above the rectangle. So my first x value is going to be a 1. Then pretty much every half after that, because the graph is consistently decreasing all the way through here. It's not changing. So my second rectangle, the height is going to be determined by the x value of 1.5. Then 2, then 2.5, then 3. And my last rectangle, this last one, the edge is at 3.5. I don't continue out to 4. That's the other edge of my rectangle. So I'm going from 1 to 3.5 by halves. So what I need now is I need this height. The height is whatever the y value is at this point. So the y values are always going to be the height of your rectangles. And because I know, all I've got to do is put my 1 back in here, 1 divided by 1. 1 divided by 1.5. 1 divided by 2. 1 divided by 2.5. I'm going to let the lists do all of this, not the table. The table would generate all these values for me, but then I've got to manually find each area, and then I've got to manually add them all up, where the lists do all of this for me. So I'm going to go to the lists, and if we've done this before, it'll come back to you. So you go to Stat and Edit, and I want to clear out 3 lists. So I'll go up and hit Clear, come down, get up on the name, clear, arrow down. It doesn't clear until you arrow down or you hit Enter. Clear, Enter, then it clears them out. So in my first list, I want to enter all 6 of these values. So it was 1, 1.5, 2, 2.5, 3, and 3.5. Now what I want it to do, and I want it to do the same thing with all of the values. I want it to be 1 divided by each of these numbers. So remember, we can go all the way up to where the name of the list is at and say I want 1 divided by every number in list 1. Remember, list 1 is right above the 1 key in yellow. The glare is terrible here. Second, L1. And now when I hit Enter, it does those 6 dividings. And all I want you to write down is the first one, which was 1, and the last one is 0.29. You don't have to fill in the middle ones for me. If you've got the first and last, I know your middle ones are right. The only row you have to fill out completely is the top row. Now for areas of these rectangles, well, I've got all of the heights, and I know the widths are all 0.5. So all I've got to do now is tell it to take every one of these heights and multiply by 0.5. So for this, I'm going to go to L3 and say take everything in L2 and multiply by 0.5. So I'm going over here. Take everything in L2, because those are all of my heights, times them by 0.5. And this is the area for each of the 6 rectangles. I didn't have to do all the multiplying. The list did it all. And again, all I want you to do is write down the first one and the last one, and I'm going to know everything else in the middle is correct, because you've got all the right x values up here. So the first area is a half. The last area is 0.14. And again, we can add all of these numbers up if you go to, I believe it's List, over to Math, and down to Sum. So it was List is in yellow, over to math, and then sum. Oh, I'm in the wrong, so I got to get out of here. Quit. Let's go list, math, sum, L3. So the sum here, 1.59 square units. Okay, so it's not too bad if you use the lists. Even by hand would not have been hard to do. It's been a lot of work, a lot of multiplying and adding. Okay, that's your upper sum. Now for the lower sum. Let's do an L6. L stands for lower sum. 6 rectangles again. Okay, I don't need to make another graph. I need my three row table though. X, Y, area. Let's see. I need to know what my X values are. It's the only row you have to fill in completely. Well, forget that I drew in that rectangle now. Now I want a lower sum. So when I look at this first rectangle, I've got a choice of the left edge or the right edge. The edge that's going to keep me under is this edge here, the X value that starts at 1.5. So this time, my first rectangle is going to be determined by the X value of 1.5. Then that will give me this rectangle here. Then the second rectangle is going to be determined by 2, and then 2.5, 3, 3.5, and I'm going all the way out to 4. So this time my table starts at 1.5 and finishes at 4. So 2, 2.5, 3, 3.5, and finishes at 4. So our first one went from 1 to 3.5. Now we're going 1.5 to 4. So going back to the list to get the corresponding y values, it's just going to L2 and say do 1 divide by everything in L1. Because this first row is going in L1. So if I go to Stat, Edit, I'm just going to delete the 1, have it start at 1.5, and then go to the bottom and add in a 4. That was quick. So now I want to clear out these two lists and recalculate them. So to get the corresponding heights, because the equation is 1 divided by x, and every x number is in my table, I'm going to say go 1 divide by everything in L1. So my heights are 0.67 for the first one, 0.25 for the last one, and the list has all the ones in between. Now for the area of each of these rectangles, remember the y's are the heights, and the widths are still 0.5. So for this list, I'm going to say go take everything in L2 and multiply it by a half. So I'm going to go up to the top, L2, oops, not divide, times by 0.5. Now these are all of my areas, 0.33, 0.125, and now I want it to add up all of those 6 values that it has. So that's under Math, nope, List, over to Math, and then Sum. So List, over to Math, Sum every, whoops, keep staying in there, quit. Got to get out of that table before you do it though. List, Math, Sum, everything in L3. 1 point, what is that? Oh yeah, I guess that's all right. 1.22 square units. So the actual area we know is somewhere between 1.59 and 1.22. The midpoint might get us a little bit closer. So our last one we're going to do is an M6, which is the midpoint sum with 6 rectangles. So all I want you to do is give me the 3 row table with 6 columns. The only row you have to fill in completely are the x's, and then I just need the first and last. So I need to know from my graph what's my first x value. Well, if I look at my partitions, I know this is 1, I know this is 1.5. The midpoint there is going to be 1.25. And then they're all 1/2 unit apart. So my first x value is 1.25. If I add a half onto that, I'm at 1.75, 2.25, 2.75, 3.25, and then 3.75. And I should have 6. 1, 2, 3, 4, 5, 6. Got that. Double check before I move on. Good. Okay, so I need to enter those 6 values in my list. So I go to Stat, Edit. I'm going to clear all of these out. Once you get the handle on what's going on, these are actually pretty quick. So I just need to enter these 6 values manually, and then I let the calculator do the rest of the work. 1.25, 1.75, 2.25, 2.75, 3.25, 3.75. 1, 2, 3, 4, 5, 6. Okay. Now to plug these back into the equation, I'm just going to go 1 divided by everything in L1 because my function was 1 over x. Wherever I see an x, I just put the L1. So go up to the top. So you're on the list name to do this. 1 divided by everything in L1. I only need the first is 0.8 and the last is 0.27. No need to fill in the middle. Then the last one is to actually calculate the area, which is length times width, or height times width. These are all my heights. Those are in L2. And the width, the rectangles haven't changed. They're all 0.5 width. So take everything in L2 and multiply by 0.5. So my first area is 0.4. My last one is 0.13. And now I just need the calculator to add these up. So we're going to sum, and that's under quit. I remembered to quit this time. List, so second stat, over to math, sum, L3, and it's adding up those 6 areas. 1.38. And that did come out in between my 2 values, so I probably did it right. Probably a little bit closer to the actual area under the curve. Okay, that's it in a nutshell. The last thing I want to show you is the program that's going to go with this section. Just like we had that trapezoid rule before after we learned how to do it by hand. Okay, the program, and we'll transfer these tomorrow in class, is called Riemann 83. Okay, now I just want to show you how the program works. And I'm going to go back and do, I'll just do the first one, the upper sum. So, get this so there's not a glare. Okay, there we go. So you can see it's number 5. Hit enter. It says it finds the area under f of x on a given interval using Riemann sums. Increasing the number of partitions gives better estimates. Press enter. F of x. So you need your equation. Our equation here was 1 divided by x. Okay. Lower boundary. That means what's your left edge of your shaded region going to be? For us, it was 1. The upper boundary was 4.